Hi guys, it's Mr. Den. I hope you're all doing well. If you have me, you know how these videos usually go. If you have Mr. Hill or Mr. Walsh, this is how it goes. Mr. Hill is going to record your next video for Unit 7. This is the last section that you guys have in Unit 6, and it's just applications of logs. So you guys have learned all the different rules and properties and how to solve the equation, so we're just going to use them in some word problems today. At this point, your warm-up is up here. I recommend you pause it and try this on your own. So pause it at this point. After you pause it, come check your answers. I'm going to go through how to do them on here. These should be pretty familiar for you. You want to write everything in terms of log base b of 2, log base b of 3, and log base b of 5 because I have a, b, and c for those values. So when you look at log base b of 10, we know that 10 comes from 5 times 2. So I can think of this as log base b of 5 times 2. And we know when you have a log condensed, if you want to expand it out, we can make it log base b of 5 plus log base b of 2. We know log base b of 5 is c, and log base b of 2 is a. So your answer is just going to be c plus a for this one. Same thing for the next one. We know log base b of 5. So if I want to write this out separately, we're going to write log base b of 5 minus log base b of 4, but we don't know what the log base b of 4 is. We don't have that yet. But you do know that 4 can be written as 2 squared. So if I think of that as log base b of 5, we already know is c. So c minus log base b of 4. Like that. And then I'm going to rewrite it as log base b of 2 squared. And anytime we have an exponent, the exponent drops down out front and becomes the coefficient. So it's c minus 2 log base b of 2, and we know from the directions that log base b of 2 is just a, so this will become c minus 2a. For the next one, same thing, but you want to think of 5. When we have a square root, we know a square root can be written as 1/2 as the exponent. So I'm going to write that as log base b of 5 to the 1/2 minus log base b of 6. And now we need to figure out how to rewrite these in terms of log base b of 2, 3, or 5. So the first one, the 1/2, can come out front, and we'll have log base b of 5, which we know is just c. And the next one, we need to write 6 as the product of log base b of 2 and log base b of 3. So I'm going to write it as log base b of 2 times 3. And then I'm going to rewrite it now as 1/2 c, but I'm going to say this is minus, I'm going to put in parentheses, log base b of 2 plus log base b of 3. And then I'm going to take that minus and distribute it in, and I'm going to replace it with the a, b's, and c's. So it's going to become 1/2 c. Log base b of 2 is minus a, because this is an a right here. So I'll have this thing becomes a, and log base b of 3 becomes b. So since I'm distributing that negative in, I'm going to get minus b as well. And you'll leave your answer just like that. If you have the a and b switch for this one, it doesn't matter. It's the same thing. For the last one, I'm going to go a little bit quicker on this one. I'm going to think of 27 as 3 to the 3rd. And I'm going to think of 20 as 4 times 5. But we know that 4 can be written as 2 squared times 5. So if I go ahead a little bit, I'm going to have 3 log base b of 3, because this exponent comes out front, and then minus, and then it'll be, I'm running out of room here. I'm going to erase the prior question. You guys can check your answer. You saw what it should be. I'm going to write this as 3 log base b of 3 minus, and then in parentheses, log, I'm going to put this 2 squared as the 2 goes out front, log base b of 2 plus log base b of 5. This becomes, 3 log base 3, or log base b of 3 will be 3 times b, so 3b. This will be right here. Log base b of 2 is a, so we'll get minus 2a, and then I also have a minus here, which will be minus C, and you can leave your answer just like that. Okay, so that's your warm-up. Make sure you're good with that. You guys did some practice of that last week, so you should be good. Applications of logs, what this unit's going to be, or this section's going to be all about. I'm going to do a few examples with you. You're going to have a few to try on your own. For the ones that you try on your own, I'll just put the answer up there, check it, make sure you got it, and you can move on from there. First one we have here is a population increases 14% per year. You currently have 500 people. How long until there are 2,000 people? So this is thinking back to our exponential growth that we started this unit with. So the first thing you want to do is think of your formula. Formula we learned for exponential growth is y equals a, which is your starting amount, 1 plus r to the t. There's no compound interest or anything like that for this one. We're not saying how many times it's compounding in monthly or anything like that, so we're going to stick with that formula. We have your rate right here is your 14%. You're starting with 500 people. That's your A, your initial amount, and you want to know when there's 2,000 people. So we're going to plug in all those values. So I'm starting with 500. It's growing 14%, so I make that into a decimal. And I'm trying to figure out how long, so I'm trying to figure out T when we have 2,000 people. Now, before when you guys did this, you had to plug it into your table in your calculator and find the T value that correlated with 2,000 as your Y value. But we know how to solve these equations now. So the first thing you're going to do here is divide both sides by 500. Because we're going to try to isolate the exponent, or the power. So that's going to get me 4 equals. And then over here I can add these up. So the 500 goes away. We get 1.14t. And then in order to solve that out, we're going to have to take the log of both sides, because that's going to bring this and make it the coefficient out front. So I'm going to put a log up front right here and a log right here. And now it's going to be log 4 equals, and this t is going to come down out front as the coefficient, equals t log 1.14. And then from there, we just need to divide both sides by log 1.14, log 1.14. These will cancel out. You'll be left with t equals, and then you're going to punch log 4 over log 1.14. And this is a common log with a base of 10, so you type that in your calculator, see what you get, and it should come out to be t equals 10.58 years. Which answers the question for this one. So make sure you have your units. You can round it like that, and you should be good. Okay, for number 2. It's going to be very similar to this, except now I'm saying you invest $3,000 into an account that grows 4.5% monthly. So we have an interest rate again here, and you should be, I'm trying to figure out how long until the money doubles. So let's think of our formula for compound interest. Our formula is A equals P times 1 plus R over N to the NT. Okay, these formulas aren't going anywhere, so make sure you're good with those. Plug in all the values I'm giving you. I'm saying we're starting with $3,000. 1 plus, my rate is 0.045 when I convert it to a decimal. I'm saying it's compounding monthly, so that means it's compounding 12 times a year. So I'm going to plug in 12 there, and I'm trying to find how long until it doubles, so I still don't know my t. So I'm going to put a t right there, and I'm saying I want it to double. So you're starting with $3,000. For it to double means you're going to end up with $6,000. Now from here, we're just going to solve for t, so we're going to plug in a bunch of stuff to our calculator. First thing we're going to do is divide by 3,000 on both sides, and you'll get 2 is equal to, and then I'm also going to type this part in my calculator so I can get an answer for it. That comes out to be 1.00375, and then to the 12t. And then if you think where we're at right now, it's just like what we did in the first problem. So from here, we took the log of both sides. So I'll take the log here, the log here. We know that this is going to come down out front, so I'm going to end up with log of 2 is equal to 12t log of 1.00375. We're going to divide both sides by, I want to isolate the t now, so I'm going to divide by 12 log 1.00375 on both sides type it in your calculator. I already typed it in, so I should have an answer. You should type it in as well to make sure you're getting the same thing. T is isolated. You should get 15.432 months. Okay, so the process is the same for all these questions. You just have to make sure you're using the right formula and then solving for the variable I ask you for. I do want you guys to try this one on your own. See how you do. Pause it at this point. Try it out. Once you think you have an answer, you can play the video and your answer should be right here. If you read the question, it says how long will it take $1,000 to grow to $16,000. So I'm starting with $1,000. I'm growing to $16,000. I have an 8% interest rate. And it says compounding daily, so your n is 365. I plug in n right here. I'm trying to find t. So start plugging some stuff in your calculator. Divide by 1,000. You can put this whole quantity into your calculator and get an answer for that. Take the log of both sides, and then your 365t will come down out front. Divide both sides by 365, and the log, let's see, 365 log 1.0021917. Try not to round until the very end so you make sure you have all your numbers right, and you should get 34.661 years. Okay, so that is how those questions are going to look. We're going to try one with the natural log because it's definitely a little bit different, and we want to make sure we're using the right formula. So it says you invest $10,000 into an account on the day that you turn 22 years old. You probably recognize these questions from the beginning of the unit. The account averages 8% APR compounded continuously. We had a certain formula that we used for continuous compound, and it had this E in it. So the formula was A equals PE to the RT. Anytime you see continuous compound. So I said, how old will you be? So we're saying you're starting out at 22. If you find out that you should be 18 years old, then you probably did something wrong, so you can't get younger with this stuff. So you are investing $10,000. That's my principal. E, your rate is 8%, so it's going to be 0.08. I'm trying to find T, and I want to know when it reaches $250,000. So let me move this over a little bit. Of course, it's not going to work. Nope. Rewrite it. We're trying to reach $250,000, starting with 10,000. E to the 0.08t. All right, when we solve these out same way as before, divide by 1,000 or 10,000 on both sides. We should get 25 is equal to E 0.08 to the t. Now, anytime you're working with E, we know that E works with natural log. And so E is the same as a log, or natural log is the same as a log base E. These are the same thing. So rather than taking the log of both sides, we could take the log base E, but we're going to take the natural log of both sides now. So the ln of both sides. And that's going to get me ln of 25 is equal to the ln of E, and then the same thing, the exponent becomes the coefficient, so it's going to be 0.08 t ln of E. Okay, now we're going to do the same way, but you need to think, if we're thinking of the ln of E, well, if we write it out as with a log base E of E, and we had to evaluate this, E to the what gives me E? E to the first. So if you were to type in the natural log ln of E to your calculator, you're going to find out this thing right here is just equal to 1. So that kind of goes away because you're multiplying it by 1. So now we have ln of 25 equals 0.08t. Divide both sides by 0.08. And we should get t is equal to 40.236, which means it takes about 40 years for your account to reach 250,000. But my question was, how old will you be? So we know you started out when you were 22, so if it's going to take an additional 40 years, you should be 62 years old. Okay, so it was 40. I got rid of the decimal for this, plus the 22 years that you had already lived. So 62 years old. Same thing here. Try one out on your own. It should be very similar. We're compounded continuously again. So pause the video, try it on your own. Make sure you get the same answer as me. Here you're asked for the interest rate, so be careful with that. Interest rate is R instead of T. Here's the answer for it. Start the same way. It's compounded continuously. Put $5,000 in a bank. That's your principal. It takes 17 years for you to double your money. So we want to know when you end up with $10,000. I'm asking you what the interest rate was for you to be able to double your money in 17 years. So same way, divide by 5,000 on both sides. We get 2. Take the ln of both sides. The 17r comes down out front. The ln of e I told you was just 1. Divide by 17 on both sides. You get 0.041. And if we want to provide the interest rate, you write that as a percent, so 4.1% when you convert it back. I'm going to give you guys one more for me to do, one more for you to do, and then we'll have an exit ticket that you can check your answer with as well. This is going back to half-life now. If you remember the beginning of the unit, we did half-life after we went through compound and then compound continuous. So our formula for half-life was y equals a to the times the quantity 1/2 T over N. So the half-life of caffeine in Mr. Walsh's body is 6 hours. In the morning, he enjoyed 290 milligrams of caffeine in his Wawa coffee. After how much time will Mr. Walsh have 110 milligrams of caffeine in his body? So you're trying to figure out T for this one. So we said the half-life is 6 hours. The length of one half-life is always N. So when I start plugging values in, it says he started out with 290 milligrams. I'm trying to figure out T. The length of one half-life was 6. And I want to know when is he going to have 110 milligrams in his body. So you want to know the time that correlates with 110 as your Y. When you solve these out, just like before, divide by 290 on both sides. I'm going to leave it as 110 over 290. That way I don't have to worry about rounding anything. 1/2 T to the 6, or T over 6. Take the log of both sides. Exponent's going to drop down out front, so you have T over 6. Sorry about that. You have log 110 over 290 equals T over 6 log of 1/2. I'm going to divide by log of 1/2 on both sides. Now you're typing this into your calculator. Once you have that, you're going to have, log of 110 over 290. If you want to get a decimal answer at this point, you can. Over log of 1/2 equals T over 6. Multiply both sides by 6 to isolate that T. So whatever you get right here, multiply it by 6, and you should come out to get, once you type in your calculator, just make sure you're getting the same thing as me, 8.391 hours. Okay, so the process is solving these is the same. If you wanted to get a decimal earlier, you can. Just make sure you're not rounding too early. For the next one, you try it out on your own. Pause it at this point. Try it out. See what you get. Be careful. Your time is in seconds for this one, but it should work out all right. Here's the answer for it. 300 grams of an unknown radioactive substance decays in 112 grams, or to 112 grams in 180 seconds. So I said you were starting out with 300. You're ending up at 112 after 180 seconds. That's your time. I want to know the length of a half-life, which is N for this. So you are going to divide by 300 on both sides. Take the log of both sides. When you do that, the 180 over N comes out front. Divide by log of 1/2 on both sides. And once you divide by that on both sides, you end up with this equals 180 over n. To solve that, multiply both sides by n, so you get 1.421463748. N equals 180. And then divide by that big long decimal right here, 1.4 whatever, on both sides, and you should end up with 126.63 seconds. You can leave your answer in seconds for this one because you were given the question in seconds. You could convert it to minutes if you wanted to, and it would be a little over, it'd be about 2 minutes and 6 seconds. Okay, so that's the last one for this. There is an exit ticket here that I recommend you try. It's really not requiring you to use log, so try it out, read through it, pause the video at this point. Once you get an answer, check it with mine. No logs required here. You're just plugging in different values. Just make sure when you see compound continuously, you use APERT as your formula. Your homework or the practice worksheet you're going to do it goes along with this will be posted in the folder on Schoology right below this, so make sure you do it. Check your answers when you're done. There's a Dropbox for you to turn in your work.